Okay, let us discuss this problem. So this says we have a metal disc of radius A, that is 25 centimeter, and it rotates with a constant angular velocity omega about its axis. Find the potential difference between the center of the center and the rim of the disc. So what we have a something like the disc is given to you, and this disc gets rotated about this axis. So let us say this disc is rotated with angular velocity omega about this axis, and the radius of the disc is also given to you. So this radius is A. You have to find what is the potential difference between a point center, let us say this is the center, and a point somewhere here on the rim, so OA. So we have to find what is the potential difference between A and B. That is the thing we have to find. What is the potential difference we have between point A and B? Are you getting or not? So how will you proceed? And this contains charge. Are you getting or no? It does not contain charge. So only thing is omega and A is given. And the first case, question says the magnetic field is absent. So let us discuss the first part, A part. So there is no magnetic field. So B is 0. So now if I consider any electron on this disk, what will happen? If I see this electron has a tendency to go outside. This means this electron, if I consider, this is also moving in a circle of radius r. Are you getting or not? So if I see this electron, so let us say I have an electron, this electron is here. So if I consider an electron is here, this is a tendency, or this is basically moving in a circle of radius r. So this electron is moving in circle of radius r. So this means there should be a force that should be acted in the center direction, because anything is moving, it has to has a force. Are you getting or not? And this force, if I see, so there should be a force in the radial direction, that is toward the center, and this force should be equals to m omega square r. Are you getting or not? So this force must be electrical in nature. So let us say there is electric field at this point. So at this point there is electric field. Let us say E is the electric field at this point. This electric field is a function of r. We'll discuss. So what is the force? If you have a positive charge, force will be acting in the outward direction. If you have a negative charge, this force will be acting in the toward the center, and this force is Q into E. So force, I can write this is E times E. Are you getting or not? So this is force, and this is equals to m omega square r. So from here I can calculate electric field. So electric field is m omega square r, and this divided by E. Now you see, electric field is a function of r. Are you getting or not? So this is m omega square by E into r. So radially proportional. You see, I can write this electric field is equals to m omega square by E. This is m is the mass of electron. M is the mass of electron. Are you getting or not? So m is what? So this is the mass of electron. So this is the mass of electron you have, and this time r. So electric field is a function of r. So if you want to plot this electric field, you will have this electric field be something like this. At r is equals to capital R, you will have maximum, and after that you will have no electric field. Are you getting or not? Because this is the electric field is coming because of the omega. So you see, now I can calculate, if I know the E, I can calculate what is the potential difference between this point O and potential difference A. So what we have to have, so let us say this is my point O and this is point A. Are you getting or not? What we have a potential electric field at this point. I know the electric field at this point. So if I consider this length is r, so this length is r. If I consider a small distance dr, so potential is given as E dot dl. Let me, don't worry about the sign. So first calculate the magnitude of potential. So magnitude of potential is given by E dot dr. Are you getting or not? And this is the integral you will have. This is not a line integral, simply E dot dr. So this will give you potential difference. So now let us try to calculate this integral. So now I know the value of E. What is the value of E? E is m omega square r divided by E and dot dr. And E and dr both are basically, so electric field is in this direction. Electric field is also in this direction, radially outward, and dr is also radially outward. So E dot dr will be basically 0 degree angle. So E and dr are basically parallel. So cos 0 is equals to 1. So now if I calculate, I have to integrate this is 0 to a. So if I integrate this one, this becomes m omega square E divided by 2, and integration is a square. So this is the potential difference between center and rim you have. Are you getting or not? And now which will have higher potential? Let us say try to see. If we have this electric field, we have already said electric field will be this side. So you have to have electric field in the outward direction, because I require force on the electron in the towards the center. This is possible only if electric field is in the outward direction. So this means, what is the direction of electric field? So electric field, so if we have this disk, electric field is radially outward. Are you getting or not? So this is the direction of electric field. So electric field is radially outward. This means rim is at higher potential and center is at lower potential. Are you getting or not? So rim is at higher potential. A rim is at higher potential or center is at higher potential. If you have electric field in the direction is this, so electric field in this direction potential decreases, so rim is at lower potential. So this means I can say rim is at lower potential. Because electric field decreases, you have minus del B over del X is equals to Ex. So if potential electric field decreases or electric field increases, then potential decreases. Are you getting or not? So this relation, so you will have, if you see there is a charge, due to this charge electric field lines something like this, at infinity I know the potential is 0, and here I will have some potentials. Let us say this point I will have some potential q by 4 pi epsilon naught r. So this charge is q. So this means potential is decreasing. This means this at higher potential. So this means electric potential decreases in the direction of electric field. Now let us discuss the part B of the problem. So part B says what we have. We have this time a uniform external magnetic field B is present perpendicular to the disk, and now we have to discuss the case again. Are you getting or not? So this time let us say this disk is rotating again, and this is the disk you have. Are you getting? So let me write again. So this is the disk you have, and this disk is basically rotating. So let me rub this one. Okay, so this one, yeah. Now this disk is rotating with angular velocity omega. So let us say this is the axis of rotation. Are you getting? And now this disk gets rotated with angular velocity omega. This has a charge or minus charge, because I am considering electron, forces on electron. Now there is a magnetic field that is perpendicular to the magnetic field is perpendicular to the direction of plane of this disk. So let us say this B is present. Now if I see any charge, let us discuss the minus charge, electron. So what are the forces that is acting? So F is equals to, now I know Q B cross B. This time if I see an electron, this is moving in a circle. Are you getting or not? So this electron is basically moving in a circle. So at any point this electron has a tangential velocity, and this velocity is equals to r into omega. So this distance is r and the angular velocity is omega. So if you see an electron, it has a velocity. So let us say if you see an electron, what you will see? So this electron has a linear velocity r omega, r times omega. Are you getting or not? So this means now I can calculate force. So what is force? Q V cross B. So let us discuss force. Force is Q V cross B. Q is, let us say, force on electron is E, and V is r omega, and B is magnitude is V. What is the direction between V and omega? Sorry, B in B. So V is this and B is upward. So what is the direction of V cross B? So if I have B is up, so V cross B is basically this is outward. Are you getting or not? So if V cross B is outward but the charge is negative, so B cross B becomes, Q V cross B becomes inward. So this force as inward force on electron. Are you getting or not? So this is inward force on electron. Are you getting? So this means this force will try to push these electrons towards the center. So electron will be collected at the center. Are you getting? So electron will be collected at the center. Now you see this force, again I can find what is the potential difference between center and rim.